As we've seen previously, if we have an object resting on an incline, we have the force of gravity acting vertically downward. We can replace this gravitational force, or the weight of the object, with a component perpendicular to the incline and a component parallel to the incline. And the components look something like this. They can be found by drawing a rectangle, one side perpendicular to the incline, and the weight vector going from one corner of the rectangle to the diagonally opposite corner. The components, the parallel component here, will be proportional to one side of the rectangle, and the perpendicular component will be proportional to the other. If the angle of the incline with horizontal is theta, it's going to turn out, when we get through the trigonometric analysis, that the parallel component is w times the sine of theta. Perpendicular component is w times the cosine of theta. What then happens is we have this perpendicular component, and if there are no other external forces acting on the object, the normal force will set itself up to be equal and opposite to the perpendicular force. That's a result of the elastic properties of the ramp. The perpendicular force pulls the ramp down, the ramp deflects slightly and pushes back, and the force pushing back is the normal force, perpendicular to the ramp. We also have a force of friction, and this force of friction can be at most some multiple of the normal force. Now, I've got arrows over the normal force here to indicate that that's a force. I really should have put absolute value signs and an arrow around here to indicate that's the magnitude of the n vector. Didn't do that, but understand that this is the normal force in this context and not an abbreviation for newtons. Okay, so as we say, this frictional force is less than or equal to the coefficient of friction multiplied by the normal force. We say less than or equal because when the incline is level, horizontal, flat, we have a perfectly good normal force. We could multiply that by this coefficient of friction and get a pretty good sized frictional force. But there is no frictional force. When the incline is level, anything sitting on it is not going to experience a frictional force unless there's something attempting to push it. The frictional force resists whatever is attempting to move the object. And if nothing is attempting to move the object, the frictional force is zero. The frictional force can at most be coefficient of friction times normal force. We'll go into more detail on that, but this is your first look at the idea of the coefficient of friction. And what we want to see is, as the incline increases, this perpendicular component decreases, which means that the normal force, which is the elastic response of the incline to the perpendicular force, is also going to decrease, which means that the maximum possible frictional force is going to decrease. At some point, the parallel component of the weight will become great enough that it overcomes the largest possible frictional force, and the object starts sliding down the incline. So there's an important conceptual idea here. You need to understand where all these forces come from and how they work together to make things happen the way we observe they happen on a ramp.